quadratic functions and equations. You guys are going to learn how to graph and solve quadratics. Okay? Again, this should be like the third time that you, potentially the fourth time that you've seen it. You learned about quadratics in Algebra 1. You apply how to solve quadratics when you were doing some things in geometry, and then you have it again in Algebra 2. So it doesn't hurt to have them one last time before you hit that final level, because this is something that you guys should know. Some of the stuff should already be reviewed. Some of the stuff should already be in your memory. Okay? So to start off, the definition, a quadratic function is one of the form y equals ax squared plus bx plus c. Okay? Its graph is in the shape of a parabola, and everybody should know the parabolas look like a U, either a U pointing up or a U pointing down. Okay? The standard form of a quadratic, it has its individual parts. You have your A, you have your B, you have your C, which all mean different things on the graph, which are the parts that are used when you use the quadratic formula to solve, etc., etc. Okay? So the example that you have is 2x squared plus 2x minus 4. That first part is your ax, that second part is your bx, and then that last part, including the negative, is that c. Okay, anytime either A, B, or C is negative, you want to make sure that you include that, or it has a minus, you make sure you include that sign, and that is standard form of a quadratic. Stop me. Okay, the axis of symmetry, though, it is a line that divides the parabola into two congruent halves. Okay, it divides the parabola into two congruent halves. The equation for the axis of symmetry, which you will need to know, is the formula x equals negative b over 2a. It does include the x equals because it is an equation. So you do need to remember this formula, and you need to remember is x equals negative b over 2a. The b and the a come from the standard form of that quadratic. Okay? So in the example where it says find the axis of symmetry, I abbreviated AOS. Okay? Y equals x squared minus 2x plus 3. Well, we use the formula. It is x equals negative b. What is b in this problem? It is a negative 2. Okay? All over 2a. What is a in this problem? 1. Okay? Now, the formula is negative b, so if b is already a negative number, a negative and a negative make a what? Positive. Make a positive. So this becomes a positive 2 all over, what's 2 times 1? 2. And then 2 divided by 2 is equal to 1. Now, the one thing I don't want you to do is put an equals 1 and say that you're done. It is an equation, and please just make sure that you rewrite it with the x equals, and then that is your axis of symmetry. So the axis of symmetry, it goes straight through your quadratic, and it intersects your parabola at the vertex, which means that when you find the axis of symmetry, you are also finding the x-coordinate of your vertex. Okay? When you find the axis of symmetry, you are finding the x-coordinate of your vertex. Okay? So they're the same thing. Slow me down. Let's talk about the y-intercept. Now, the y-intercept is what you get when you plug in 0 in for every x into the quadratic. Okay? So in your standard form of ax squared plus bx plus c, if I plug in zeros everywhere I see an x, then you are just left with c. Okay? The y-intercept is where the graph crosses the y-axis, and when it's in standard form, the y-intercept is always the c. It's always that constant, that number that doesn't have a variable. As you can see, 0 squared times a goes away, b times 0 goes away, and you're just left with c. Always, always. So again, to find the y-intercept, you plug in 0 for x, or if you notice, if the quadratic is already in standard form, like this one is, x squared minus 2x plus 3, you automatically know your y-intercept is the 3. The one thing is, though, is y-intercept is a point. So it's, how would I write the point? 0, 3. Okay, it's always the c. Going through all the properties of a quadratic. To find the vertex. To find the vertex, that vertex is that point. It is that bottom point or it's that top point. That basically where the graph goes from positive to negative or negative to positive. And we need to find the x-coordinate the same way we find the axis of symmetry. What was that formula? So to find the vertex, we need to basically find the axis of symmetry, negative b over 2a. Once we find that x-coordinate, to find the y-coordinate, we take that number and plug it back into the original function. So that f represents the function, and then the negative b over 2a is that number. You plug that back in and you solve. Okay? So let's find the vertex of this same quadratic of x squared minus 2x plus 3. Okay? I know we found the axis of symmetry before with this problem. We're going to do it again to practice. The formula is negative b. What's b? Negative 2. All over 2a. What's a? 1. A negative and negative make a? So that's a positive 2 over 2, which becomes what? 1. The x-coordinate of my vertex is 1. To find the y-coordinate, you plug the 1 back into your function. So that's going to be 1 squared minus 2 times 1 plus 3. That's how you find the y. You plug the x-coordinate of the vertex back into the original function. And please, order of operations, if there's a number in front of that x squared, you always square the number first and then multiply. What's 1 squared? What's 2 times 1? So what's 1 minus 2 plus 3? 2 or 3? Or 2 or 1? It's 2. So my vertex is at 2, 1. Now this is definitely not the graph that goes with this, but that's how we find the vertex of the quadratic. Okay? 2, 1. Or 1, 2, I'm sorry. The y-coordinate of the vertex represents either the minimum or the maximum value of that respective quadratic. Okay? So if the graph opens up, then is this a min or is this a max? It's a min because that means the graph, this is going to be the lowest that it goes. So this would be technically a minimum value for this particular problem. Okay? If the graph opens down, then this point is called a what? It's called a max. And so then the maximum value would be whatever the y-coordinate is of that respective point. Okay? Questions? All right? Let's talk about the graph. How to actually graph this. Okay? Now, the way that I go through with graphing is I need the vertex of the parabola. Okay? Now we just found the vertex. What was it? 1, 2. Okay? So what I do is I take the vertex and I plot that point. That is 1, 2. From there, I follow a pattern. Okay? The pattern for a quadratic. Well, first, before I go through the pattern, let's determine, does this graph open up or does it open down? If you ever wonder, look right here. These are a few notes. If a is greater than 0, and remember a is the number that's in front of the x squared. If it's greater than 0, then the parabola is going to open up and have a minimum. But if a is less than 0, then the parabola is going to open down and it's going to have a maximum. Okay? So open up means it's going to look like so. Open down, it's going to be pointing down. So does this graph open up or does it open down? It opens up. A is a positive 1, so it's going to open up. Now the pattern. You start from your vertex, and you go up 1 and over 1, and then that's another point on your parabola. Up 1, over 1. The next point on your parabola, going from the point that I just plotted, you go up 3 over 1. After that, I'm going to be outside of my graph. Okay? up 6, and then over 1's the next one. Okay, but up 1 over 1, up 3 over 1, and you have 2 points on one side of your parabola. But because this is symmetric and there is a axis of symmetry that cuts your parabola in half, you can find the other points by doing the exact same thing just on the other side. The pattern is what? Up 1 over 1, and then up 3 over 1.
And if there was another one, it'd be up 6 over 1.
And if there was space, it would be up 6 over 1. But really and truly, if you can give me 5 points, the vertex, and 2 on each side, then we're good. Okay? And that's it. What happens if you forget the pattern? What is always your fallback to graph anything? Make a table. Okay? So you can always make a table and plug in a few points that are on the left of your vertex, on the right of your vertex, and do that. So I could have plugged in -1 and 0. I already know what 1 is. Then I could have plugged in 2 and 3. And when I plug in 0, I get 3. 0, 3. That's my y-intercept. It's the point that's on the pattern. Okay? If I plug in -1, that becomes 1 plus 2, which is 3, plus 3 is 6. -1, 6. That is that point right up here, the pattern. It works. Okay? It works. Questions? Let's finish up this foldable, and then we're going to do a few more just to make sure y'all understand the pattern. Okay? So, can't do this without domain and range. Y'all know this. Okay? But a quadratic, it opens up or down, but the graph's going to continue to get bigger and bigger and bigger. So the domain is, of course, going to be all real numbers. And y'all can do the symbolic notation. You ain't got to write out all the words. Okay? The range is all real numbers either less than or equal to the maximum, or all real numbers greater than or equal to the minimum. So what does this mean? This basically means that you don't really need the entire graph to know what the domain and range is, okay? First off, the domain for any quadratic is always going to be all real numbers, okay? So it doesn't matter if it's x squared minus 2x plus 3 or -5x squared plus 15x minus 21. The domain is always going to be what? And you can write that in set notation or interval notation, whichever one you feel more comfortable. Tell me, which one am I writing this in? I heard set, that's the first thing. So the set of x values such that x is always your range. I don't need to know what the graph looks like. Granted, we did just graph it of the next graph earlier. But is this a maximum or a minimum? It's a minimum because it opens how? It opens up, which means we need the minimum value. The minimum value is the y-coordinate of the vertex. What was the y-coordinate of the vertex? 2. Because it was 1, 2. That was the vertex. So then the range is all real numbers greater than or equal to the minimum value. How do I represent all real numbers greater than or equal to the minimum value? Close. We're talking about range, so this has to be the y's. So we'll have y such that y is greater than or equal to 2. And y is what? So I just need to know if the graph opens up or down and basically what the vertex, the y-coordinate of the vertex is. And then I have the range. If I wanted to write this in interval, this would be 2 to infinity with a what around the 2? And a what around the infinity? Parentheses. Very good. Let's talk about the pattern a little bit before we go on to solving, okay? The pattern is up 1 over 1, and then up what? Up 3 over 1. That is the pattern for any quadratic where A is 1, okay? Where A is 1. But A is not always going to be 1. A could be any number it wanted to be, okay? For example, What if the quadratic was given to you and it was negative x squared plus 3x? I want this to be nice. Okay. Make this a nice number. Plus 4x minus 5. Okay? The negative means that instead of going up 1 over 1 and up 3 over 1, I'm going to go down 1 and then over 1. I'm going to go down 3 and then over 1. Okay? And I do that pattern from what point? From the vertex. Okay? So, all right, so I wanted you to find the vertex of this quadratic, and then I wanted you to graph it, okay? So what's the formula to find the x-coordinate of the vertex? Negative b over 2a. What's b in this problem? 4. What's a? Negative 1. Remember, if it's a minus or a negative in front of that number, it goes with that letter. Okay, so then this becomes negative 4 over negative 2. 2 negatives make a? Positive. So 2 is your x-coordinate. Also, this would be your axis of symmetry if you had an x equals. So now, to find the y-coordinate, you plug it back in. And remember what I said. If there's a number in front of that x squared, you follow order of operations and then apply the number in the front. So what should you have done here? The squared. What's 2 squared?
4.
And then made it negative. 2 times 4?
8.
And then minus 5. And so what is that number?
Negative 1.
So my vertex is at 2, negative 1. So when I graph this, I'm at 2, negative 1, and this graph should open up or should it open down?
Down.
How do you know?
Because negative and 5.
It opens down because A is less than 0. So from there, I do the pattern. What's the pattern?
Over 1.
Down 1 over 1, and then?
Down 3 over 1.
And you do it to both sides. Down 1 over 1, down 3 over 1. So a rough graph, rough makeshift graph. Okay? And I was actually wrong on the pattern. I had to double check myself. After 3 is up 5 over 1. Not up 6, but 5 over 1. Let's look at another one real quick and then we'll go into solving. What if it said y equals 2x squared minus 8x plus 1? Okay? The pattern of up 1 over 1, up 3 over 1 would be affected. It would be multiplied by what number? 2. The 2. Whatever the A is on the outside, it affects the pattern. So I'm not going to go up 1 over 1 and then up 3 over 1. I'm going to go up 2 over 1 and then up how many? 6 over 1. No matter what, you're always going to go over 1. It's the up and down that's going to be affected by that A value in the front. Okay, that A value causes a vertical stretch or shrink. That's why it's only affecting the up or down part. Okay? So that's your pattern. This is the original. This is the OG. This is the transformed one. Okay? So whatever A is, it affects the up part. Okay? So find the vertex of this one, and then I want you to graph it. What is the vertex in this problem? 2, negative 7. Anybody not get 2, negative 7? Okay? Remember, you do negative b over 2a. Negative b over 2a. So that's how you get a positive 8 over 4, which becomes 2. When you plug that value in, make sure that you square it first before you multiply by 2 to get your corresponding y value. Okay? So 2, negative 7. And then the pattern is going to be up 2 over 1. And then up 6 over, and then you just repeat on the other side because the axis of symmetry cuts that quadratic half. Okay? There you go. So whatever that A is, it affects the up part, never the over. Over is always by 1. Okay? And if you happen to forget the pattern, you could always make a table. Okay?